Okay. So thank you for joining today. And the topic for today is how we can implement 3D design in order to create STEAM projects using Arduino or robotics with MBOT 2. So I believe it will be a really exciting session, since by using the technology of 3D printing, you can reach this point by creating accurate and real projects at this time. I'd like to, I have the robot to bring it, so I'll cut my presentation for a while. Thank you for understanding.
समझने की समझ में नहीं आया मेरे को.
Okay. So as we all know that for many years, the technology of 3D design shown development and enhancement in order to reach, as we know, better results, especially for students. And with the integration of the platform Tinkercad from Autodesk, make this revolution a real. And now we can see that more and more students are really engaged in this technology. When I talk STEAM, I have to give this definition that anyone can understand, even without any educational background in the field. So when we talk STEAM, actually, and if somebody asks us what is STEAM and how to implement it at school, actually the definition is very simple. It's a kind of combining many skills in order to let students create a new design or a new product. And this new product could be to solve a problem in our real life as innovation, or rethinking and redesigning for an existing solution, but aiming to perform more or to reach, let's say, a better result for this. This is why when we talk about STEAM and when we talk about combining many skills in order to deliver a product, it means that those skills will be for science, technology, engineering, art, and math, and all those all those skills, excuse me, will handle at the end a real product, a real solution. And in order to realize it, I need tools. And those tools, regardless of the robotics and the Arduino, the microbit, or any kind of technology, I need to reshape a product. And by that, I need to or use it by assembling every object I have around me at home, in the classroom, anywhere, and to recreate this product. And then the other solution is to redesign it and to create it from scratch on a 3D design. So so this is why implementing the 3D design printing is really a must in order to reach this solution. And now you can imagine that the technology of 3D design printer is in reach. I mean, the printers now are delivering high quality and high resolution of product. This is first. Second, they can the price is affordable, and we can find online many ready design to be explored. And when we talk about 3D design, we have like two paths to take into consideration. We have the first path, which is a path that does not require precision and high quality of design, where students will be introduced to Tinkercad, and we will be asking them to perform those skills in terms of technicality, okay, to know how to use and to manipulate the software or this platform. And the other path is to be accurate 100% in order to create accurate product to fit in with any kind of microcontrollers, Arduino solution for product, like I'll be showing you in a while, or even for robotics or for that. This is why during our presentation today, I'll be showing you the two paths and trying to explain you and to show you, give you some examples for that. I'll start by sharing my screen. So I'll share my screen and I open Tinkercad. And I believe you all know this platform. We already did many design on this platform. I'll try to recap in a quick way. So by clicking on the create and selecting the 3D design section, it seems like my internet is a little bit slow. All right, so I can see the platform or the work plan. By clicking on the right click of the mouse, I can change the orientation. And on my right side, I have all the basic blocks that I need to use in order to create any shape I want. So here, like for 15 minutes max, I'll be showing you the main manipulation that you will be doing in order to use all the tools and all the techniques in order to create, I'll say, any product without precision. All right. So if I move a box, and by clicking on one of the edges here, the small white squares, I can see that I can identify the dimension with length and height. So I can change easily those dimensions in millimeters. Okay. And if I click on this small black triangle, I can raise my object from the floor. And of course, if I want to rotate my object, I can do it even from this side, or this side. So this is as simple how I can edit all the properties of my object. Now I'll move to another step, which is how to create holes inside the box, because when I talk STEAM, I talk about combination and alignment and creating holes in order to create those definitions. So I'll take, for example, a cylinder. It's always 20 by 20. I'll make it like 10 by 10. Okay. And I want to place it in the center of my red object. So all I have to do, I can select both. I click on alignment. And here you see that you have many black circles to define where you want to align. So by clicking on the circles, you see that it will simplify the alignment in an automatic way. I click outside in order to deselect the two objects. Then I select my cylinder. And now, in order to create a hole inside, I am obliged to click on this icon, which is hole. And then when I select again both objects, I go to my my icon group, and you can see that now the hole is created. As simple. Okay. And if I click on this object and I want to duplicate it, let's say 5 times or any number, so I can click here on duplicate and repeat. So it's already duplicated on itself. So when I click using the left or right keys, I define the final position of the copied object. Then I click 1, 2, 3, and 4. I can select them all, and I can place them wherever I want. So here, I'm quite sure that all the objects are created with the same dimension, and the distance between them is the same. Now let's move to another example, which will be more practical, which is how to create two gears synchronized on a base. So I'll start by creating a cylinder. I will make my height for 5 millimeters, and the dimension is like for 25 by 25. Then I create another cylinder for 5 millimeters, and I change the dimension manually in order to make it like one of the gear that will be duplicated on the cylinder. So I assume that this is it. First of all, let me remind you that in order to make the sides smooth, here the number of sides, I make them like 64. So it will give me the effect of 100% circle. And even for here, it will give me the same effect. So what I'll do, I will make, let's say, my selection. I will place the gear inside the cylinder. I will make sure that, sorry, excuse me. I will make sure that objects are aligned. And then I will create on duplicate. I will move my teeth, and then I will rotate it. Hopefully it will work. And then I will click. It's not working. I forget the technique, excuse me. Long time I did not practice it. Okay. I remember. So when I align my object, I click on duplicate and I move it to the parallel side, and I make sure that it's always symmetric. I believe it should be like this, I think. No? I believe this is it. Okay? And then if I click on the first object, I press on Shift and I select my other object. Okay? Now I click on duplicate and I rotate this way, and I click on duplicate and duplicate, and then you can see that my gear is created. All I have to do is to select all the objects and then click on group. And you can see that I have actually a gear. Okay? Now I have to create a hole inside the gear just to place it on the base. So I'll take a cylinder for like 15 by 15 with a height of 10. I will transform it to a hole. I will try to place it inside the gear and to make the alignment. And then I will combine. And here I have my first gear. Then I duplicate my gear, and then I can see that there is 2 gears here placed that I can rotate in order to see if they will fit together. So what I need here is simply a base. I will select both, or even no need for selection right now. I will create the base for like 5 or 3 millimeters. I will make it bigger in order to have it on the 2 gears. Okay. Then I will take a cylinder and if you remember, the hole I've created is like for 15. So I create a hole for, I define the size of the cylinder for 14. by 14. Okay. And no need for all this height. And I will select both in order to make them center. I will change the color in order to make it clear or visual. Then I will take my gear. I will make a bit bigger, as you can see. And of course, I have to raise my gear for like 5 millimeters in order not to be for 3 millimeters, excuse me. All right. So here I select my object. It needs like to be bigger. I will delete this, no need. So I select all. I will take my, in order to make sure that everything is aligned. Okay. Here, I think that I have to reduce, it's less than 1 millimeter. So I will take it like 0.25 in order to make the grid smaller. So I can make it 100%. Now I'm quite sure that my object or my gear is centered on the base. I select both, I duplicate, and then I move to make sure that the two axes will be 100%, will fit 100%. Okay, so I take the second gear and try to rotate to see if it's okay or it needs more to move away. So it seems like you can see that it's not working very well. So I will select again. I will select again my I will select the base and I will make it okay. So like this, the two gears will turn without any like scratching inside. So I will select all. I will deselect the base in order to center all this. And the moment I finish, imagine that this is done. Look how the two gears will turn smoothly. So what I can do, I will click to select. Now it's ready to be printed on the 3D printer. So there is a step that I have to do. I will select the two gears. I will move them without changing the space between them. Okay. And in order to print them without a support, I will place them on the bed. So at 0. So like this, I will select the green axis and the red support. I will merge them. So here I have my item ready to be printed. How to send it to the 3D printer? You need one step from the Tinkercad, which is I click on export. I select the extension STL. And here the document is generated. Here it is. So I can click. You can see that my document is ready. I can take the file and convert it on the software for my printer, depends from the brand you have, and then it will be printed without any problem. So this kind of manipulation, actually, it needs just 1 second. It needs precision, but I'm not obliged with a specific dimension that I have to respect. I mean, I'm creating something with high precision of working and thinking, but nobody tells me that, for example, the diameter of the gear should be like 4 centimeters or 5 centimeters and so on. However, the second path of working on Tinkercad requires dimension that I have to respect. And for this example, I'll be showing you a project that I have done previously, which is the base of a parking gate, where I design it on my Tinkercad and I print it on my 3D printer. And on this, let's say, base for my parking gate, I have created a hole for the servo motor, another hole for the push button, 2 holes for the LEDs, and 1 hole for the 7-segment display screen. So by that, okay, I'm planning to create something which is really accurate, but the idea is how to obtain those dimensions. I have one of 2 options. If I take the ruler that I have, dimensions will not be 100% precise and accurate. Why? Because we are talking in dimensions with less than millimeter. So with this ruler, I cannot. That's why I have to go for one of the 2 options, which are, or I will use my digital caliper, or I will go on internet and check for the dimension online. So if I want to take or to use my caliper in case I have one, so first of all, I have to close it well, to click on the on button. So you will have the value 0. I will open my caliper, and then I will take my my servo motor and close it in order to see the width, which is 22.7 millimeters, and then the thickness will be for 11.7 plus minus. All right, so this is hopefully the good dimension. The other technique, I will go for the internet online, and let's say I will go for real dimension for a servo motor. I believe it's a it's a 9G, I think, 9J. Let me check. If I take images, okay, this is it. So look here for the different pictures I'm having in order to see the dimensions. So if I click on this picture, I can see that the dimension I'm having here, it's like 12.2. I will check again the dimension I'm having here. So it's like here for, it's like almost, I don't know if it's accurate because my students played a lot with it. It shows me here 11.7. So it's less than 1 millimeter. So almost it's the same. And the width is 22.7 or 22.5. We are talking in millimeters. So here it's 22.9. And the height is like 18.3, as you can see here, it's like 18.3. So based on those pictures, I'm quite sure that my result will be almost accurate. So I will go for let me take the dimensions. So it's like 12.2 by 22.9. So if I want to create a hole for this servo motor, so I'm obliged to go to the 3D design again, okay, to create a box with the dimension I'm asking for, which is like 12.2 by 22.9. All right, I will transform it to a hole. Sorry, I will transform it to a hole. And if I design, I will put all this aside. So if I put my design here and I will make it bigger, so I will move the hole that I have created for my servo motor. I select both and then I click on merge, and then the hole will be created. But here to tell you the truth that you have to check it on your printer, because sometimes you need like 1 millimeter in addition in order to make the servo motor comes inside correctly. Because if the hole will be the same size of the servo motor, it will not fit again inside because they are the same size. The hole should be at least 1 millimeter from each side bigger in order to insert it. And as you can see here on my design, it's a perfect design. Even we thought about the base, not to have it in a one structure, because you have to know that the moment I finalize my design and then I sent it to the printer, I have two options to print. Even I put it like this, and then the printer will print it vertically. And since the wall does not have a big thickness, it's thin, so the result might not be 100% accurate. So that's why you should think of another solution. So we have to make it horizontal. But the problem is, since I have the base and here there is an empty space, so in order for the printer to print this in plastic, it should create a support here. And the support, it's from plastic, so the result will not be really good as you can see on this. You ask me why you took this model, not maybe this model. So because this model, I can put it like this on the bed. I will print the wall and then the base without any support. Maybe it could fit, but the problem is that when you will print this with the base from one side only, you will notice that it's not standing 100%, especially when you insert the servo motor and the other devices. So you feel like it's not entering. Okay, from this side. All right. So you feel like the wall will fall down, because we are talking about the center of gravity, which is not holding the whole well. So that's why the other solution is to have the base alone, to have the wall alone, and to create this structure with a hole here that I can make, I can print them both like this. And when I finish, I will join them. And if need to add a glue, I will do it, no problem. But here, I'm sure that my structure will hold 100%. Okay, so same for the push button, for the LEDs, and for the 7-segment display. So I try to see if I have some structure made previously for this. This is it. Okay, so this is it. I will click on it. Okay, I will make it public later on in order to. All right, so you can see here that how I design it, okay, and how I place both on the bed in order not to have support. So it will fit 100%. I will ungroup this one. I will ungroup to show you the dimension of the hole I've made for the servo motor. So it's like 22.5 by 12.2. So it's a little bit bigger than 22.5 by 12.2. It's almost the same I have here. So I will select again, and I will join in order to keep my work for later. Back to my previous page. Now I'll move to another section in this 3D design. So, and before moving, I can tell you that as a summary, that the steps to do in order to create 3D designs for Arduino will be the same. Always, you will be needing real dimension for the items you are using. Like, for example, if I have this ultrasonic sensor that we use a lot in our Arduino projects, so I can design, I can use this base in order to insert it and to make it like this. And later on, I will add my servo motor to it. I can fix it here. And when the servo motor will turn 180 degrees, I have the servo motor taking the ultrasonic sensor left and right in order to make a control on the room if there is any suspicious or any movement on it. By the way, I forget to tell you that by the end of this session, like in 15 minutes max, I'll be sending you a link in order to fill. Then I will send you the recorded session plus the summary of this webinar, and for sure a certificate of participation for the 4 days that we are handling. So back to this, I'll move to once I finished my section regarding how to create 3D design for Arduino in an accurate way. I showed you how to manage the servo motor. It will be the same for the 7-segment, the ultrasonic, any kind of sensor. Now I'll be moving to the robotics. And since we are using in our curriculum the leading robot EMBO2 nowadays, so we can say that I need to reshape or redesign my robot in order to create additional functionalities. And since my robot, it has holes from all sides, from left side, right side, in front and behind, so I'm quite sure that I'm quite sure that I can create a design in order to add a robotics arm or to add a structure for defining or changing the structure of the of this robot. So here I have a servo motor. As you can see, it's a servo motor, all right? And I was asked to create a structure to hold this servo motor and to transform it to a hand in order to grab objects that are in front of. So I started by designing the structure. I will open it. So it's public. You can have it if you want. Search for me on, I believe that this is my, those are you can search for Wissam Dakash, and then you can download the designs I'm placing publicly. Okay, so back. So you can see that how precise I should be in order to create this structure. Okay, so it took me a quite time in order to try and to change and to update and to modify to reach the right structure in order to capture correctly the cubes that I'm using with this robot. So basically, you can see that I have two arms, but there is an arm where my structure, I've added to my structure two blocks with a little height, and here less height. And for that, it's very simple. I've added like this because the first one, which is this one, it's fixed. It's not opening and closing. So I don't want to have this small two walls to touch the cube. Instead, I've added two holes here, since this side of my robot or my arm will open, so it will not cause me a problem for that. And you can see that I've added here, like I've stick with the glue like a sponge in order to, when I close my hand, it will fit in a correct way, and it will not move the other cubes that are next to the cube that I'm catching. And finally, the base that I've created here is here. It's the color is black. So this structure is to fix on the skeleton of the robot, and at the same time to hold the two structures that I have as hands for the servo motor. So you can see that those design are made in a precise way after taking the dimensions, after trying them. So it will be really an interesting step for you to move forward with them and to try them with your students in case you want to integrate the STEAM for Arduino, for robotics, for MBOT, for the microbit or other technology tools. And as you saw that the idea is really simple of exporting those items in order to transform them into a 3D design. So that's why you can see that by clicking on export, everything is done. So I select the STL and it's already done. I'd like to mention that other structures will be created and posted on my public account in order to make sure you will profit from those structure in case you want to integrate them with your students. I have to say maybe my presentation reach till the end. Before, I'd like to show you a structure I made for my servo motor if I want to fix it on a table. So I designed this structure, and you can see that I've created a hole for the wire, and here my servo is fine. He will not fall down. I will stop my sharing. I will ask you to stay for just one moment to share with you the link in order to fill the form. And then just all right. So I will have the link. I will share it with you on the chat. There is a question. I will be answering it in a while. So please, on the chat, I have sent a Google form. I'd ask you to please fill the form in order to receive the recording, the summary of this presentation, and the certificate of participation. Mrs. Hani asked me how much is supposed to be the distance between the object and the work place to print it correctly using the 3D printer. It should be 0. It should be 0. Okay, so please go ahead, start filling the Google form in order to receive all the documentation you need.